Hello everyone, in this video we will learn about electric polarization. We are having two types of material, conductors and insulators. Conductors are metals and the structure of matter is just like there are positive kernels and electrons are flowing between the kernels, and when the external field E0 is applied, an induced field EP will be generated of magnitude exactly same as the applied field. So net field inside the material will be zero. But in case of insulators, there are two types of material, polar, where positive and negative charge is separated as shown in the picture, and non-polar, where positive and negative charges center are coinciding. These are non-polar. So when the external field will be applied, the non-polar molecules first will be polarized, then they will align themselves as shown there. But if the electric field is applied to the polar molecules, they will simply align. So it is easy polarize polar material. Here, this is a prototype model where this green colored electric field is applied from positive to negative direction. First, these molecules will be polarized as shown. First step, then in the second step, these polarized molecules will be aligned themselves like this. So in two steps, a non-polar molecule can be polarized and a net electric field will be generated inside the non-polar medium, and the direction of electric field will be from positive to negative. This pink sign is the external electric field, and here induced electric field is from positive to negative, but the net electric field is E naught minus EP, which is not zero. Here in the polar molecules, there will be only one step. When electric field will be applied, they will simply align themselves. Like if external electric field will be applied like this, simply these molecules will be aligned themselves. So it is easier to polarize a polar material. Here again, internal field will be set up, induced field, and applied field is in the direction of this pink arrow. But here, net electric field in the medium will not be zero because E naught is greater than EP. Now, it is shown here behavior of a conductor in the external field, as we have already discussed. Inside the conductor, net field is zero because in the metal, applied field is exactly same as the induced field. And if inside electric field is zero, definitely the charge enclosed inside the charge conductor will be zero, and this is a concept of electrostatic shielding. And total flux through the charge conductor will also be zero. Here in the charge conductor, if electric field is zero, which is equals to negative gradient of potential, V should be constant. Electric potential will be constant inside and on the surface of the charge conductor, and electric field is always perpendicular to the charge conductor, because if it is not, there must be flow of charges on the surface of a charge conductor, which is not possible. E cos theta component is 0, which makes theta 90, which proves that there is no surfacial current on the charge conductor. And electric field due to a charge conductor can be calculated with the help of this Gaussian surface. As shown, total flux is equals to q by epsilon naught, and electric field is sigma by epsilon naught as calculated. Thank you.